All right. Hello, hello. Happy Thursday. We're going to pretend that we didn't do this already and that a crash ended the YouTube stream. It failed to recover. And so we kept streaming for 15 minutes over on Twitch until we realized the YouTube stream died. And now on Twitch, it looks like we're running back-to-back ads again. All right. Today is not our day, but it's all right. We're back. This will be a short stream. It was already going to be a short stream, but now it's going to be a shorter stream. But that's okay. We have something we're going to do. I guess I'll do a very short version of a short recap of what we were doing yesterday. Not to bore everyone who obviously hasn't been here for the last 30 minutes. I'll make that about as small as it can get. So, here we go again. Yeah, I just want to farm that ad money. Yeah. You're heading out? All right, no worries, Sapphire. We're literally doing nothing today except compute shaders, which is going to be frustrating and probably yield very little visible behavior. So, I don't think you'll miss much. Tomorrow will probably be more fruitful. Take it easy. Gotta remember which window has focus before I just start mashing keyboard. All right, so let's make something here. So we're going to fill the screen with like a block, and we're going to kind of watch what happens to our performance as we do it. And what this is showing to me is that there is some static cost to rendering. And in theory, canvas item, which is what we're using to render this stuff, doesn't suffer a lot because it should only be, it's only queuing a redraw when something actually changes, which is a performance optimization that we are taking advantage of. And yet there is some static cost to rendering, like we're rendering this huge volume of tiles. We're not doing occlusion culling, so we are rendering every single tile. So like this is like a really rough, unrealistic test. However, we are now down to 51 FPS and 20 milliseconds. Okay, the physics process spike is definitely related to when I remove my cursor from the, you know what I bet it is? I bet it's the cursor mapping system. No, that doesn't make sense. I don't know what it is, but something freaks out whenever I remove the cursor from the window and bring it back. But yeah, 20 milliseconds is not good. If we look at our visual processor or visual profiler, all of our time is being spent rendering. All of it's being spent rendering, and it's all being spent on the CPU. The GPU is doing nothing. The GPU is being utilized for less than a millisecond. Oh, I'm sorry. It's being utilized for 400ths of a millisecond per frame. So what I was talking about before we crash, well, I wouldn't say before we crash, but what I was talking about in the pre-show, we'll call it the pre-show, is there is some static cost to rendering. We could probably get in and figure it out, and we could also probably reduce it with tricks and tactics in the simulation to reduce the amount of drawing that we have to do, to reduce that load. Problem is, all of the processes that would improve that would also use CPU to calculate that. So while we might be able to reduce the number of things being drawn, I am not convinced that we would be able to reduce the overall amount of CPU being used by a significant margin. And because this game needs to have a good performance profile, we want it to be like, we want an early version of the game, Lo-Fi Flyby, which is almost like, we could think of it as almost like a kind of demo that we're working towards of the underlying tech and everything. We want that to be like a desktop companion app. I want this game to run. I want the full game to be able to run on like the Steam Deck. So we want to aim, we need performance. We need good performance. We need a low performance profile. And we do not have that. And right now we're doing everything on the CPU and nothing on the GPU. So our approach today and tomorrow, and for who knows how long, some number of days, hopefully not weeks, hopefully days, at least at first. There's a lot we could eventually do with this. We'll probably go down the rabbit hole. We are going to offload as much of the rendering to the GPU as possible. Try to get these bars to look a little more balanced. We are going to do that with compute shaders. No problem. We are gonna try to additionally be using the main rendering device instead of a local rendering device. So we are gonna try to keep everything on the GPU. We're gonna try to keep it's gonna be finicky. Computer shaders are finicky. I've done this before in Unity. The last thing I did in Unity was like a scriptable render pipeline, like isometric voxel renderer. That one was kind of in 3D, but it was actually very close to what we're trying to achieve here. That was 3 or 4 years ago, so I don't remember how to do it, but we're gonna do it. We're gonna find out. And we actually have a great starting point. We have an incredible starting point, posted just a few weeks ago by another YouTuber who's does educational content for Godot. Not for Godot, but, you know, educational content in Godot. I don't think the 20 millisecond thing is, we're isolating the Z index layers. So there's like 192 canvas items, Nix. We are rendering content on like 50 to 60 of them when I do that task. we are usually only updating 5 or 6 of them when the cursor is moving around. So we are isolating the change. So we're not Q redrawing. The system is drawing everything every frame. But again, according to the documentation, canvas item is good at this. It's good at this part. It should be saving us some of that. It's just, there seems to be other things. The real cost seems to be drawing something on the screen. Not queuing the redraw, not whatever. The real cost seems to be just having a canvas item being drawn on screen. And so far, nothing we've done has made a significant dent in that cost. So we're just going to try something else. We're going to try something GPU-based. And we're going to take a look at a video from the Pathfinder's Codex. I think I posted in there. Hey, Mugiwara, how's it going? Hey, Nanigans. I will pin this person's channel on the YouTube VOD for people who are interested. They're great. A few weeks ago, they posted a video. They also have all of their stuff on GitHub, which is also great. How are you doing, Mugiwara and Nanigans? We had a bit of a false start earlier. I don't know if you were there for it. We tried starting around 45 minutes ago and everything crashed and the YouTube stream died. And then we kept streaming on Twitch for about 15 minutes until we realized what happened. And so now we're doing a bit of a short second attempt at this episode, which is good because I only have so much stomach for compute shaders. Yeah, this is a great channel. I'm going to try to reach out to this creator. I really like their content. We're really interested in this using texture 2D RD with compute shaders in Godot video. This is the one that we're really interested in. I'm not going to play it because I don't want to strain anything. Typically when I try to watch YouTube while I'm streaming to YouTube, weird things happen, so I'm going to avoid doing that. But what's great is the project that this video is from is right here. And it's available in open, and it has a permissive MIT license. But that's fine. We're not trying to copy substantial parts of this code. We are interested in one aspect of this project, which is the output GPU texture, which is writing to the GPU texture. Here, I can get a picture from this video probably. I'm gonna put this, yeah, we're gonna get an ad, so I'm gonna bring this over here and find this part of this that I want. Biology exam for you tomorrow, Mugiwara. Oof, good luck. Nick, so those are a lot of canvas items. You're guessing the system needs to add everything together, then render the final image. You could say throw the stuff into the buffer and reuse parts that do not change. You're not familiar with Godot. Yeah, this is all, our solution is going to be Godot specific. It's not a lot of canvas items. I mean, it is thousands. It's less than we're rendering many tiles, but we're doing it with less than 200 canvas items, which doesn't feel like a lot of canvas items. Because typically a canvas item is each individual little guy running around, right? Each individual little sprite, each individual little thing is typically its own canvas item. We're actually doing a lot of optimizing by packing a ton of draws into individual canvas items. But I'm still not convinced. Like, I don't think there's a big trade-off between having a ton of canvas items versus having a few canvas items. There seems to be some bottom line when you're using their process with the CPU kind of rendering approach. There seems to be a cost to just X number of draw calls. And I don't mean draw calls in terms of like instanced rendering or batched rendering or whatever, because when we profile the thing, we only have like 7 draw calls for the whole thing. So it is batching it for us. So it's as efficient as I think it could be. I think it's doing a lot of mess with pushing textures. I think every time we do a draw call, it's like pushing the texture over again for the first time. I don't know what it's doing. We'd have to dig so far into the engine code and the rendering server stuff to have any idea what it's doing, and I don't know how that works. And so we're just gonna, I understand there's more things we could try with this approach. I don't think it's worth trying. I think I think there's a little bit of more of a local maxima to gain here. I don't think it's worth it. I think we're coming back down off the mountain and looking for a better global maximum somewhere else. That's what I've decided. I've decided we've kind of reached the limit of a pure CPU approach, and we're just gonna not bother continuing down that path. We want a GPU approach because our GPU isn't doing anything. And it's not like we're targeting, phones. It's not like we need to worry about that. We're targeting like computers, like PCs, Steam Deck. So we have a GPU. I think we can count on a GPU, and I want to just do this stuff GPU. I think that's the way to do it. Yeah, Nanigans. A canvas item is essentially a quad and a texture. 200 quads isn't much. It says we're rendering 55,000 primitives, so somewhere something is happening. Nanigans, fun fact, web browsers essentially work in the same way by drawing a quad and painting a texture on top. That's what allows GPU accelerated scrolling. Oh, neat. So yeah, we're going to offload as much of this stuff onto the GPU as we can. There's an open question of like how far upstream, like how much of the calculation that the canvas item system is doing, the canvas item drawing system is doing now, how much of that do we push down to the GPU? We're going to start by not really pushing down much. We're going to send over the data we need to send over. But we're not going to... There's a world in which we could try to have a bunch of the calculations offloaded onto the GPU. I'm going to take a conservative approach at first, and we're just going to have the GPU worried about drawing, per se. But we could definitely... There's a world in which we could offload more of this. We're doing GLSL stuff. And apparently I don't have a text editor that can handle GLSL. Like the Godot engine can't do it. So we're just writing it in Writer here. God, I had it show all. Yeah, there we go. Optimizing stream, compute shader stream, Arneo. I'm not criticizing your approach, Nix, in terms of like, I think your approach and your thinking on this is very correct. I've just spent long enough, like, trying to identify the problem. And I think we need to just look for a different problem. And I think getting the GPU to carry its weight is a good problem that we can actually dig into. So we're going to be using a compute shader. Compute shaders are super simple. They're all basically the same, but they're also all a little bit different. And honestly, most of the work involved... Mugiwara, why don't you release your game in a demo version or early access? We will. We definitely will. We have a roadmap. We could look at our roadmap sometime. We have a roadmap for that. Man, this is going to be a terrible VOD. I'm like rushed. I acknowledge I may be in a bad mood. I have not gotten enough sleep. And it's been an ongoing struggle. And I thought I wasn't going to have to do this again, but here we are. Here we are in Compute Shader land. Now I have to remember how to do this. Hey, Jerry FGC, thank you for the follow. Sorry I missed that. Appreciate you. Nix, speaking of cooking, you made dal yesterday. You also lost a kilogram. That's unrelated. Okay. Dal. I don't know what that is. Okay, we're still watching ads over here on this Texture 2D video. Here we go. So this guy is doing absolutely incredible things. All right, I'm gonna risk showing this. This is incredible stuff this guy's doing. I don't know if I've seen some of his other stuff with their life simulation and stuff, but look at the stuff being rendered back behind me here. Isn't this incredible? Keep an eye on my dropped frames here. We seem to be doing okay. So here's some cool stuff, which is why I want to play this video. Which is, that was the workflow. Hold on, I want to go back to this. So this is like normally how things work with a compute shader. You've got like, you run your compute shader on your GPU, you write stuff out to a buffer or a texture. The CPU reads that buffer back, converts it into an image, and then uploads that image back to the GPU for drawing. This is what we want to avoid. We don't want this GPU to CPU to GPU thing every frame. And our canvas item draws does something like this. It doesn't do the GPU, obviously, compute, where that's a different process, but there's a core issue here, which we do want to address, which is this back and forth. We want to write to the GPU once from the CPU for the buffers that we need to, for any of the data we need to include externally. But we want the GPU to write to the buffer, to the output texture, and then read from that output texture without ever having to send that output texture back to the CPU, which is very doable. And this video explains how. Dal is an Indian lentil curry. It's really nice. You eat it with rice and bread. Oh, it sounds good. I do like a good curry. I know how to make a red lentil curry, but I wouldn't say I'm particularly good at it. So there's a few of these things we're going to do. This is all going to refer to... Look at the simulation stuff that he's running. This is incredible stuff. I've seen this. Someone showed me this in the context of some stuff they were trying to make. They wanted to do this Conway's Game of Life kind of stuff, and this is incredible stuff. Look at just how much rendering is happening, just fluidly. So yeah, we should be able to achieve some incredible rendering performance if we achieve this. Hey, no Jewel. Yeah, this is from the Pathfinder's Codex. They have some really incredible compute shaders, and it's time for us to write a compute shader for this game. Yeah, so we're gonna bounce around to this because we don't actually need to watch the video. All of the code involved in this is available. So if we go to this person's channel, we go to their GitHub, we go down to this project. This is all available. This guy's awesome. Their stuff is all available with an MIT license, but that's, you know, we're not trying to copy significant portions of this code. We're interested in one aspect. I love this Game of Life stuff. We're not doing a Game of Life thing. I'm interested in one tiny aspect of this, which is the compute shader interaction, which is the interaction between the computeparticlelife.gd and the computeparticlelife.glsl. There is a world in which we do the GD part of this in C#, but none of the documents are written for the C# version of this, so we're going to start with GD script. But I acknowledge that that means we're going to be sending the buffer from C# to GD script and then to the compute shader, which is not ideal. It might be okay, because we're doing things to try to minimize the amount of copying when we could transfer things from C# to GD script, from managed to native. We're trying to use fixed scopes and primitive arrays, things that can be trivially copied, or not copied, trivially referred to across that boundary with like a, you know, a pointer that's been pinned. You hate that compute shaders won't work for web exports? Yeah, at least this totally closes the door on me having to think about whether I'm going to support a web version of my game. At least I don't have to worry about that anymore. Yeah, this is gonna be easy. So this is the approach that we want. We want this GPU only compute shader, where we run the compute shader, it writes to and then reads from this texture 2D RD image texture, and then it renders that image with no CPU readback, which is great. And this is the kind of trivial graphics performance they're achieving here. I say trivial in that it looks very smooth. It looks like the performance is incredible. So I cannot wait. Because we want to do a lot of rendering, and I really don't want to have to pay a lot for it. There are doors that are just going to be closed to us now. Like, lighting is going to be very hard to do traditionally. We'll have to do our own thing. New architecture, C# backend, GDScript IO front end, GLSL rendering front end. That is so crazy, and that is very much what we're doing. Web in general has more support for compute shaders now, Nanigans. Oh, nice. So maybe not Godot specifically, but the web is coming around to it. All right. So we don't have to watch the rest of this video. I'm going to keep it over here because I might need little bits of it. I love that the Twitch chat always just becomes like a foodie discussion. All right. So these are the two scripts that we're going to be most looking at. There's a GD script that needs to, there's a lot of unrelated stuff in here that we don't care about. We care mostly about the rendering setup, how to prepare the image and the texture we're going to be using, how we're going to call the thing. We're going to need to free resources when we're done. There may be situations where we need to quote unquote restart the rendering part. So here's where we like rebuild our buffers. So we're going to be looking at all this. Yeah, my experience with compute shaders is that most of the work that goes into a compute shader is just in preparing the compute shader to run. We can look also at the compute shader docs here, which is probably a good idea to do. I thought there was a page for compute shaders. Like a whole page. Using compute shaders, here we go. Yeah, compute shaders are interesting. You need to specify how many invocations you want to make in three-dimensional space, which is fascinating. You have to very clearly define all of the data coming into and going out of the compute shader, and you have to bind everything to it. Hey, Sorcerer. For you, the pandemic was well, for a lot of people, I guess, the pandemic was the catalyst for learning how to cook. You get good at it when that's all you eat for a few years. Yeah, that's not untrue. People baking bread. Nanigans, you haven't used it yet, but the web GPU is sort of the fancy new tech to one-up WebGL, and it supports it. Okay. Okie doke. That sounds good. Yeah, so we are going to set up our compute shader. So the interesting thing about compute shaders is how work groups function. They're kind of, you end up kind of like with this structure. This is actually a really good example of how it works. You have the 3 dimensions of the work group. You have like 3 dimensions of the invocations, the local indications. So the parallelism comes up here. This is still, these are not running in parallel, the local invocations, really. Well, they kind of are. They're the individual, how should I say this? The way work gets spread out across all of this is actually kind of interesting, and I'm not an expert on it. I do know the basic things, like they're called warps, and there's an AMD. AMD has the concept of, there's like 64 in a group, and then I think NVIDIA organizes things in groups of 32. So it's one of those things where it's like, we need to split the work out. so that it can run in parallel. So part of the challenge will be figuring out where to split the work out, or how to split the work out. I think we'll probably end up, I think at first we will split the work by z-index. I think we'll start with that. We're not going to be creating a local rendering device. We're going to be using the main rendering device. So it's like, it's kind of like you can start with, you know, it would probably make sense to like start with thinking about how you would do it the normal way and then look at that, pay attention to the difference. But we might end up just diving kind of in the deep end here and just struggling our way through this. Sorcerer, you think there's some common mindset between people who make games from scratch and people who make food? Yeah, it's probably there's a DIY kind of aspect to people who do this work. So yeah, this defining the compute pipeline is going to be annoying. We have to do all this different stuff. There's so much work goes into just getting a compute shader up and running that finally once you actually call the thing, it feels like you've already done all the work before you even call the thing. But then the compute shader does all the work. We have to worry about freeing our resources. We're not going to do this. We don't need to worry about the execution here, the submit and the sync. We're going to run it on the render thread. So I've got our GLSL script here that I started writing last night, and then I just stopped because it was like 11:30, and I was like, if I keep working on this, it'll be 2 a.m. before I get anything rendering. So I decided to stop. But there's two things we're going to focus on drawing, or focus on writing out today. I don't know if we're going to get terribly far in either, but we're going to at least start. One is writing out the compute shader. I don't know why I'm calling this mosaic layer. I guess that's kind of what it is. So I think what we're gonna do is run. We're gonna run the 190. It would be good if this was a power of 2, if our number of invocations were a power of 2, because then it would get evenly split up amongst the different threads and the warps or whatever you want to call them. But we need 192 of these at first. I think there's a world in which we don't do it this way. But if we want to take advantage of that parallelization, we kind of need to have multiple invocations. Like if we just have 111 invocation, then I think it just puts us on a single thread and we don't really get advantage of much parallelization. So we want to try to split the work up. So I'm going to split it up by our Z indexes and we'll see. We'll see about that. Sorcerer, you don't even measure very much. I'm the opposite. I want very clear measurements. My partner's like that, though. My partner just channels the spirits of her ancestors and just cooks perfectly every time. No measuring. I not only need a very explicit recipe, I need multiple attempts so that I can refine my process before I'm like at all. Before I even feel like I'm following the recipe. Nanigans, you hear there's a super performant formula for drawing all this stuff out that you could just get the CPU to calculate 6 triangles in pairs of 2 and interpolate a texture between those points. If you find where you heard that, I'd be interested in reading it. We're gonna try this. Because I have a guideline. I have a way of thinking about it at first. Because I actually have 2 great examples in this project by the Pathfinder's Codex here. That's very close to what I want to do. So the first thing is defining what we're all going to read and write to. So what I've written out so far here is layout. I have a buffer, a read-only buffer called the draw buffer, which just probably needs to be renamed. Maybe I should say input buffer. So we have a sampler 2D array of textures, of input textures. All of these textures need to be the same size. So here's an annoying thing. So we've got all our textures, right? We've got our texture atlases, our different texture atlases. Like I can just open one up. I can open up our silly one, just for an example, our debug one. So we've got all our textures. All type, default block. So this is like one of our textures, right? These are the default block. At the moment, all of our textures are going to need to be the same size, but that's fine because right now all of these are the same size. Eventually, we'll switch to supporting textures of varying sizes. But the short answer is we're going to be doing our own. We're going to be managing our own little texture registry. So we'll manage the resources on the GPU. Hey, Jacob, how's it going? GPU was a bad joke. That's literally what rendering a 3D mesh is. Oh yeah, if you look up how to do this, how to do what I'm describing in Godot, almost everything you're going to get back is how to like manipulate multi-mesh to do this stuff. Because yeah, that's how people are generally doing this, I think, is multi-mesh. But yeah, we're going to have a bunch of these. We're going to have an array of these. And we will push them to the GPU, and we will get we'll push them through here by their our IDs. So we can get an ID that will consistently refer to the resource on the GPU. And we can pass that around. So that way the simulation can know what texture is associated with something without, having to explicitly know about the texture. Just have an indirect lookup there. So right now this is a sampler 2D array. It's eventually going to be an array of image 2Ds, I think, or sampler image 2D. I'm so bad with GLSL references. I have to look every single thing up whenever I try to do something like this. So these are all the textures that we're going to do. The input buffer is basically going to be our draw params buffer. Right now I'm thinking about putting it through as a single buffer. Unfortunately, I am not able to use shorts here. So the data is gonna be bigger, which is rough. We're gonna try to see how much of the data we can shed and avoid having to send, because we built out our params struct based on the idea that it was gonna be plugged into a canvas item draw call. So we picked all the things we chose to represent there based on that, but now we only need to send over what's necessary for this. And what's necessary for this is we need something like, we need the texture ID. We go in shader, Jacob. We're doing it. So even with the occlusion, it wasn't enough. The occlusion might have helped. I talked about this a little bit at the top of the stream. The problem that I was having, Jacob, was twofold. One is that there seems to just be a high cost to rendering things, even when we're avoiding the queue redraw. So yeah, occlusion culling would have helped. But the other problem I was running into is that we were using CPU time in the simulation to reduce the amount of CPU time we were doing while drawing. But the problem is we were just trading CPU time in one place for CPU time in another place. All the while, our GPU is basically sitting idle, not doing anything. So I think what's better than trying to if we're seeing this incredible difference in utilization, rather than just trying to slowly bring down the CPU time, I think it makes more sense to try to balance the load. So that's what we're going to try to do. What should the compute shader calculate? It's not just going to calculate, no, Joel. It's going to do the drawing directly as well. So it's going to be writing to a texture on the GPU that the GPU will then read to render without any CPU back and forth, assuming we do this right. We're following along with a video called Using Texture 2DRD with Compute Shaders in Godot by the Pathfinder's Codex, which I will pin to the VOD here. Yeah, we've done compute shaders. You're excited to see an application of compute shaders? Yeah, me too. I've done that in Unity. I haven't done it in Godot yet. And I did something very similar to this in Unity, so it'll be interesting to see how different this is. So here's what we need in our input buffer. Because I was talking about, we could... No, Jules right, and what we should be using the compute shader for is computing. So there's going to be a search to see, like, what's the minimum amount of information we can send over? And how much work can we have the GPU do itself? So we're going to start with kind of just the set of parameters that we are using for the canvas item draw thing. So we're going to start kind of conservatively and not ask the GPU to do that much compute. We're going to ask it to do a lot more drawing, which compute shaders can do, funny thing. What was it exactly? It was not far off from what we were doing. I was trying to do an isometric voxel renderer, if you'd believe it. And I had some success doing it with compute shaders in Unity, but we kind of abandoned that approach. And then when I came to Godot, I was like, we're not going to do it that way. And yet here we are, a few years later, being like, I guess we're doing it that way. All right, so... Sorry, I'm reading chat to figure out which messages are part of an incredibly lively discussion about cooking and which messages are for me. All right, so we need the texture ID. This is an int. This is going to be 32 bits. This is just an int. It's an int 30. I guess I'll say it's an int 32. We need the texture ID. We need the screen space. No, we need like the pixel coordinates. We need the pixel coordinates. That the pixel coordinates is int 32 x 2 because it's a vec2. So we need that. We also need the like, well, it's not just pixel coordinates. It's like output pixel coords. How do I get this all lined up? There we go. So we also need to know the input pixel coordinates. Like we need to know where the coordinates are on the texture. That's another int 32x2. You missed most of this combo. You're making bagel and lox for your wife. And open-faced breakfast sandwiches for you. Ooh, that sounds nice. That sounds tasty. I had an English muffin for breakfast. I like them. I found a new one that I really like. I read your messages, Nix. I think. I thought you had good suggestions. I just wasn't interested in trying to fix the canvas item situation. So I'm sorry if I was unfairly dismissive of it. I try not to read out everyone's messages, especially if they're replies to other people in the chat. so sorry if sorry for whenever I unnecessarily call messages. Like I don't read them because I think they're applicable to someone else or they're conversational or something. We also need to know the region, so we need to know the like texture size. We need to know the texture what do I want to call this? It's like the size. It's like the you know the pixel dimensions, which is also an int32 x2. I will always say sorry. So we need the texture ID. We need to know where in the output texture we're starting the draw. We also need to know where in the input texture we're pulling from, as well as the dimensions. Pixel dimensions being like the texture region we're interested in, as far as like I'm listing these separately because like in the canvas items we were actually listing the regions twice. We were listing it once for the input and once for the output, but they're the same dimensions. So unless I need to do like resolution, messing with the resolution stuff, which I'm not going to do, we're just going to write to a texture that's the size of the viewport, and we'll let Godot upscale things. Pancakes. I'm hungry. I just had breakfast and now I'm hungry again. So thanks, chat. Arneo, you should pay attention for once I'm doing something from scratch you could learn from. There's a video. I'll just hit you with the video. This is the video we're learning from. I'll pin this stuff in the Twitch VOD. So what else do we need? So this is 7 ints. Texture ID, output pixel coords, input pixel coords. The order is the draw order, so we don't need anything else. So if we look back at our canvas item draw params as they're currently structured, so we have the canvas rect. So this is like the position and size on the canvas. The source rect, which is the position and size on the texture. So we're saving 2 ints by duplicating, because you can see, oh, you can't see anything. So we're saving a little bit there. Oh, the modulation. We might need that. If we want to do modulation, which I feel like we want to do modulation, that's an extra 4 ints. You know what? You know what we should do? No, we can't do it that way. Ugh. We'd save a lot of space if we just had a separate work process for opaque geometry than we did for semi-transparent. Maybe we do that. Maybe we have a separate pass for semi-transparent geometry. I don't know. I kind of like to back to code and pixels. Yeah, we're coding how the pixels are going to get drawn to the screen. I added something else. So we're going to sort by z-index when we are sorting the draw params, which we don't have to because right now we are organizing the textures. I think we're going to draw to multiple output textures for now instead of just drawing to one. I think we need to draw to multiple, otherwise we're not going to get the consistent ordering. And so we sort by z-index. We sort by the y-sort, which is a positional thing, which is how you determine what should show up in front of something else within a z-index when you're talking about like an isometric situation or anything 2D. Y-sorting is helpful. And then I added an X factor, which is like an additional sorting mechanism if we do things like rendering transparent and opaque geometry in the same process. Then we could just have a higher X factor value or whatever for opaque geometry than transparent. Hey, Darren Nash, thank you for the sub. Thank you, I appreciate that. How's it going? All right, so I don't think we need these. We definitely need this. So we're at 7 right now. If we include 4 more, we're at 8. What is an RID structured like? Is it actually 32-bit? Something I actually don't know the answer to. Here we go. I mean, I guess it's in Godot, so it's a 64-bit int, probably. Does that just get converted to 32 when we pass it to the GPU? All right. For now, we're going to not include... Oh, I guess I'm in charge because we're sending the data over in byte form. So I actually get to choose how big that field is. So we have a compute shader here. We need the GD script version of it too. I need a new GD script. We're gonna call it the same thing. We call it mosaic layer GD. It is going to extend from. I guess node is fine. It's also not the mosaic layer. It's going to be the whole mosaic. That's what I'm going to call this rendering thing. Mosaic. This is going to be the thing that calls the compute shader. So this is where we're going to put all our... This is where we're going to set up all the data for the compute shader. But let's worry about the shader itself first. So I need all of this data. I need the texture ID. I need the coordinate where what we're going to draw starts on the output texture. I need the coordinate where what we're going to draw starts on the input texture. I need to know the dimensions of the texture of like the pixel dimensions of what we want to draw. I need to know that as well. And I think that's it. I don't love that this is 7 things. I would love for it to be 8 things, you know what I'm saying? But I can't think of an 8th thing we need. You know what we could do? So instead of, since it's going to be kind of free, what if we just sent over an alpha? So we wouldn't be able to do like color manipulation, like tinting, but we would at least be able to do like transparency. I mean, eventually we want to do tinting. But I don't know. I guess we could just, if we wanted to tint something, we could just draw over it with an overlay. I don't know. We're going to start with that. Put a random number in there. Hey, full box. Look. Alpha component. You don't get to talk to me that way. All right, we should probably put these in a different order. But this is the data we need. This is what's going to be in this input buffer. I don't know what order I want it in, though. All right. Everyone's a backseat grammarian. Alpaca. That's funny. All right. Who cares? This is the data we need. It's the same size as the canvas item draw params because we're going to be using full ints instead of shorts, but we've managed to remove half of the values. So that's good. So I'm probably going to need to make a new struct to hold this or something, because some of this stuff we want, but we only want it on the C# side, like our sorting mechanism. Honestly, our sorting thing could probably be could be something else. You're so lost right now. All right. Assuming that you are representative of everyone else here, we're trying compute shaders. We're trying to render with compute shaders because we are not happy with the performance profile of this. We're not happy. So this is all relatively fine. Rendering it this way via... right now what we're doing is we have canvas items for each Z index, for each Z layer. And we are rendering all of these with just direct draw calls when stuff changes. So when stuff doesn't change, we're not... So if I just hover here, we're not changing anything. However, you'll notice as I just keep adding things to this, the process time just keeps going up. Part of that is we're not occlusion culling. If we were occlusion culling, we would be getting better performance from this. Why is it still 8? I'm going to try to make a bigger block here. All right, the camera totally just went crazy on me here. So yeah, now we've got this, all of this going. Now our process time is 32 milliseconds because we've decided to draw this whole thing. So this is unacceptable levels of performance to me. Why is physics process going up? Physics process is where, well, I don't know what the spikes are. The spikes only seem to happen when I go from being not focused on the game window to being focused on the game window. But physics process is where the simulation layer is happening. So all of our C# code runs off the physics process. Can't you fit alpha and tinting in int32? Oh, you're right. We could fit the whole modulate in a single value, huh? If we just use bytes. If we store it byte by byte. You're so clever, Darren Ash. That's very correct. Yeah, the camera can move, J-Cup, which is why this is a problem. Because the area that we can render to is actually quite big. The point of my demonstration here is there seems to be just a high cost to rendering things. If you look, we're currently rendering... We're only... With 8 draw calls, we're rendering 90,000 primitives. So I don't like this. So we thought about ways... So yeah, now our physics process is just 0.7 milliseconds. So there are these spikes, and I don't know what they are. I think there's maybe a one-off task running that's hogging everything up, but we don't... It's not really important for what we're talking about. What is important for what we're talking about is this, the visual profiler. So if you look as it draws out our 30 milliseconds that were spent rendering this stuff, it's all CPU. The CPU is doing all of the work here. The GPU bar should be here. And technically it is. I can see it, but there's like 1 pixel strings along the bottom of this thing every once in a while. So we could be doing things to like reduce the draw, the draw resources. Like we could reduce the amount we're drawing by culling things away in the simulation layer. But the problem is, if we do it that way, we're just trading CPU time for CPU time. So we could reduce the CPU time by just being more efficient. But what I really want to do is I want to find a method that like equalizes the load, right? So that's why we're gonna dig into compute shaders. And there's actually a whole video outlining the exact process I want to use for this that was posted like 3 weeks ago by the Pathfinder's Codex. And that's what we're going to use. They're really great. They're a small YouTube channel like us, but the difference between us and them is we just do live stream content, and they do a bunch of sick educational stuff. They have incredible stuff. So what we are interested in is this texture 2D RD with compute shaders and Godot. Very high performance. And we're going to set that up. We're taking our time with it, tell you that. But yeah, thanks for the suggestion, Darren Ash. That was a really good idea. Not just the alpha component. It's like the color modulate. And this is byte times 4. People don't say byte 8, do they? Because that's like insane. Here, we could say this. This is also not how people talk, but I mean, technically we could use short by storing each short, by storing 2 shorts at each in 32 or whatever, but that's more than I want to do. But yeah, I think we could store this as 8-bit bytes times 4. All right, so this is our... This is nice. This is all nice and aligned, I think. Well, relatively. All right, this is what we're going to store. This is what we're going to store. This is all the info we need for this. And it's the same size as what we were passing around before, and what we were passing around before did not seem to be significant, so I'm hoping that this continues to be not significant. We have the array of input textures. We'll probably just start with 1 for now or something. I mean, I guess I'll try to set up the array. And then we have an output texture that we're going to be using. And the neat part is the output texture is going to remain on the GPU. It is never going to get read back to the CPU. None of this stuff is ever going to get read back to the CPU. I don't know if that's what read-only means. I think read-only is in the context of the compute. So we write to it from the CPU, and then we just read it here. How are you doing, Fullbox? Nanigans, between the stuff I've got going on there and the discussion you've been having with another dev trying to do voxel meshing, you're tempted to redo how you were rendering your battle maps as well. I appreciate you following me into yet another boondoggle. All right, are we actually going to do the thing? I think we're actually going to do the thing now. So, like I said, we're kind of following along with the video. Luckily, their code is all available and permissible under the MIT license. But again, we're not trying to copy substantial portions of their code. We're looking at 2 scripts, the compute shader and the GD script that manages the compute shader, which in their world, they're doing a ton of stuff with this compute shader. They're doing like all their crazy simulation because they're doing this kind of stuff. They're doing these crazy like life sim madness, which is really sick. I really like the stuff this person does. This is super cool. Highly recommend the Pathfinder Codex and their content. But we're not doing this level of compute shader simulation. I mean, we might someday, but you know, not for this. So we've got a checklist of things that we need to do, which is right here. We need to use the main rendering device instead of creating a local rendering device. We need to set up a texture 2D RD that we can refer to in GD script, but which only really exists on the GPU. We're going to do the same thing with our input textures. I need to make sure we got the right flags set up on the texture. We get the resource, and we got to dispatch it specifically on Godot's rendering thread. And then we just got to assign the output texture to a node, which is easy. So we're going to do one output texture. We're going to continue to do one output texture per Z index for now, because that's the only way I can think of to parallelize this process. And it should be good. Should be good. Rhiannon, Dave and Nanigans are doing stuff like this, and meanwhile you're happy that you finally pieced together your third-person character controller last night. Hey, the only choice we make is, you know, how we waste our time. That's the only choice to make here. I'm gonna put this over here in case I need to step through it. Any progress is progress. True. True, full box. How's Scope Creepers going? It's looking good. When can I buy it? Demo's out. Oh, hell yes. Hell yes. Scope Creepers, Steam. Oh, it's called Scope Creep. I keep thinking of Aramus's podcast, which is Scope Creepers. But yeah, this is Foolbox's game. This game is amazing. A whispering flame craves souls. With each offering, your resolve strengthens. Fight spirits, collect their essences, and feed a hunger that may never subside in this short, active incremental. Yeah, this game is juicy. Foolbox is like the juice master here. Just so much good juicy stuff that's been added to this. Very excited. And the demo is out. Oh my god, I'm gonna play this later. That's so exciting. Release date Q2 2026. Ooh. We getting close. Demo stats are pretty good. You're happy? Awesome. I'm very happy. All right. All right. You know what? I don't understand why this person makes a myVec2 struct that just contains a vec2. Concerning. Whatever. But what we're interested in, so here's our render target. We've got this set up, the RGBA32F. I think I've set that up that way. RGBA32F. We've got our uniform input textures. So at the moment, I think these are all the resources we need. Oops. Why is this on its own? There we go. If you play, leave a review. Hell yeah. Look at that. Your marketing. Look at the amount of marketing. So they have an interesting additional set of parameters that are like config file stuff. I think I'll eventually do something like this, but we're not going to do it right now. So we're not actually doing simulation on the GPU. We're just going to use it for rendering. Nanigans. There's a couple minor hiccups with the way grid map works that you've managed to work around. Long story short, it's mostly only doing multi-mesh instances behind the scenes. Has limitations with only having one mesh per cell. You can't really call the individual tiles, only entire chunks at once, and it limits the flexibility you have on the individual meshes. You could refactor that all to do your own multi-mesh rendering and control things a bit better. It would make your render grid code more straightforward. Yeah, that seems close to kind of how the way we want to take it too. Because we were doing similar things in tile map layers. All right, so what we want here. all right. So what I'm looking for, what I'm really looking for is more of the setup. Actually, the execution seems like it's going to be fairly straightforward. So what we do got to do is we got to draw per pixel here. Trying to see where they're doing this. They're doing a lot of smart stuff here. Discard if outside image. Ah, the draw radius, right. We should be fine as long as we don't make that mistake. So what I'm more curious about is setting up the compute shader. That's the part of this I'm more interested in looking at right now. So maybe we do some side-by-side stuff. Maybe, you know what's super crazy? We might actually open a file in we might actually open a GDScript file in Writer. I don't normally do this. But I think we might right now. And then put these next to each other here. So we've got our compute shader, we've got our GDScript that is going to control the compute shader. Hey, Fusionist, how's it going? Happy Thursday. Hey, Nix, you figured out your matrix problems from your mod. That's great. You're chilling today, how am I? We're wading back into the world of compute shaders. And I've been here before. And I could have sworn we weren't going to do it again, but we're going to do it again. We're CPU bound, Fusionist. And when you're CPU bound, there's only one thing you can do. Try to make yourself GPU bound. That's what we're going to do. All right. So what we're going to do here, so first thing I want to do really, look through this renderer setup here. So what I want is this, I want this render device. I don't like the look of a GDScript in a Writer, but they've added a lot of support for it. I think it's actually totally fine. All right, we need our rendering server. We need to get a rendering device. We need to get the main rendering device. So we're not going to be making a local one, which a lot of people would do in this situation. So it's not syntax colored because it's there. Syntax coloring is not great. Nix, your solution ended up breaking another code. Yeah. You got two working halves. That's how you make how you make a whole, right? All right, so we need our texture 2DRD. Texture 2DRD. I don't know if I like that. So we get that. Oh, we're going to define that later. So we're going to define a bunch of stuff. Compute shader. I might call this output texture instead of texture 2DRD. Although there isn't one output texture, huh? There's a series of output textures. That's kind of the difference between what this person did and what we're doing. So we have output textures. However, I guess this will be an array of texture 2D RDs. I think that's how you declare a texture in GDScript. I never remember. I always forget how GDScript works. All right, we have our compute shader. That's an RID. Okay, no, it's not happy with this. Whatever, we'll declare it later. Variable compute pipeline. It's another RID. Uniform set RID. Oh wait, why is there a texture RD and an output texture RID? Uh-oh. We're gonna have to see more about this. Not output textures. We'll just call it output texture. FMT. That's like format. Let's say. Can I reuse this format? This is an output texture format. It's an RD texture format. We should only need one set of these. I don't know what the view is. I also don't know why we're declaring it multiple times. I don't know what this is. You know what? That's okay. I don't have to. Do we have to make a new format and then update the view? Let me make a texture 2D RD. Texture RD. Oh, is this to... We'll figure this out. This is part of the fun. Just trying to figure out how this stuff relates to each other. So we need the compute buffers, an array of RID. Oh, is this how you do this? Okay, so we can say equals, we can say this, and then we can say 192. No? Oh, I don't want an element of it. I want... Whatever, who cares? Table flip, yeah, exactly, Arneo. Output, texture, uniform. Uniform. It'll be interesting to see how all of these things are being used. Oh, is that pancake flip? I kind of see what you were going for there. I kind of, all right, FMT. So we need to, the first thing we do is set up a bunch of format stuff, it looks like. How are we doing on time? Pretty good. You'll be an ASCII artist in no time, Arneo. Don't worry about it. Don't even worry about it. Oh, look at that ligature. Look at that arrow ligature. I think I prefer to type GD script in the Godot IDE. But I'm doing this because, although, can I just pop out the Godot script thing? I can, huh? Distraction free mode. That's all right. I'm gonna keep doing it this way because I want to be able to tab back and forth between these two really quickly. So while I don't normally do GD script in here, I'm going to continue to do it because I can't edit the compute shader in the Godot IDE. So we need to set up our format. That's the first thing we need to do here. Output texture format dot width equals. Can I get the viewport? Do I just know the viewport? I just say get viewport dot. What do we got? I don't want all this. This is not the place to look up Godot documentation. This is the place to look up Godot documentation. There we go. I don't like plugging in magic numbers. I would like to get the actual viewport size if possible, but you know, it's not like our viewport size is ever going to change. So I don't mind doing it this way. It would just be, it would maybe be nice. You know what? Maybe this can't provide me the info I want, which is fine. The less we mess with viewports, the better, probably. So we're just going to set the width to be 640, because that's what it is. I guess I could set a const. .640 by 360. That's what we do. All right, so we set that. And then what we need to do is we need to set the output textures, additional format stuff. We need to say, so wait, why do we set the width and the height? And then reassign the format. Does that make any sense to anyone else? It doesn't to me. Rendering device. Data format. So we want the RGB 32. S float. I should say data format slash RG slash R32. We want this one. R32, G32, B32, A32, S float. Okay, now what are you upset about? Oh, that's your dot format, not format. I see. I see. We're not reassigning it. I can't read. So hold on. I don't actually know what FMT is then. Yeah, it's just a format. It's not actually a file. Okay. All right. And so now we need to set these flags. This part is important. An update bit. I don't know what the forward slashes are doing there, but I don't think we need those. Oh, it's a thing. It's telling the GD script that I am like some kind of escape character. Does this actually do something? Oh, it does. Huh. It's like a new line escape thing. Neat. I didn't know that worked like that. So that's an awkward thing for me, is fitting stuff. We're still going to use a double indentation because that's what Godot expects. But I didn't realize I could just do that. I could just do a forward slash. Neat. The more you know. You know? Hey, Titan RoboDuck. How's it going? Happy Thursday. Texture. Usage. Can copy from bit. I don't know why we have this CPU read bit, and we're going to try to avoid whatever's going on with that, but all right. All right, there we go. And the view, for some reason, we're assigning the view again down here, in addition to up there, which is a little concerning. I guess we'll do that here too. I'd hate for that to be like the reason something didn't work. And then whatever this texture RD thing is, we're going to call that the texture RD is the texture 2D RD. That's an output. So we can make a new texture 2D RD. Shenanigans, you're done for work for the day, logging off. Hop back on if we're in a moment. Yeah, we'll be here for a bit. We'll probably be here for another 30 minutes or so. Today's got to be a short one, unfortunately, because A, I started late. B, the stream went down after like 20 minutes, or I had to restart the stream after 20 minutes, and yeah, I was already running late, so that's fine. Honestly, this kind of work is work that I would like to do offline, but there's nothing else I really want to work on, so we're doing it here. But I'll probably be working on this tonight as well. And we'll see what we get. We'll see what we have ready to go tomorrow, or what we're able to achieve tomorrow. All right, so I need this texture RD. going to make an output. So here we go. What we're going to do is we're going to have an output texture RD. We're going to say output texture RD equals texture 2D RD dot new. And then we'll need some kind of, we'll want to call the rendering server to restart stuff. Next, you're going to live finish as well. You have your first workday tomorrow. Nice. Yeah, that'll be great. What we should do is some of this exit tree stuff. We'll need to clean up our resources. We're not going to do that right now because we don't care. Restart simulation. So this is setting up a bunch of starting data. GitHub displays GD script very weirdly. Titan, you've tried to switch your old laptop to Linux. It has not been a fun experience. Oof. Yeah, I don't know if I would ever put a laptop on Linux. I mean, nothing against Linux. I have one laptop. Luckily, it is new enough to run Windows 11. And it's kind of my portable version of my main desktop, and my main desktop is Windows 11. But I'm going to set up, I've got 2 old computers that are ready for their second lives as Linux machines. One is going to be kind of my first home lab, like server situation. To see some fun stuff we can do with that. And the other is a small frag box that's going to be for like taking to like conventions and showcases or whatever. Anywhere that has a monitor that I can put the game up on. You're back? Welcome back. The amount of BS you've seen with Windows 11, you're just not switching to it? Yeah. That's fair. It's totally fair. I feel obliged to be on Windows because, one, I don't want to deal with a lot of things on my daily driver. And 2, the OS share of Linux on Steam is 3.5%, which is higher than it's ever been, thanks Steam Deck. But yeah, it's still not high enough where I think I just need to be living and breathing Windows still for what I'm trying to do, as much as I hate it. Rebuild buffers. When does this happen? Because we're interested in this. So when we do this, we make a packed byte array. We take our data. Where's this data? Oh, the data is a dictionary. Okay, so we're passing in all the data. We're building a packed byte array. We're appending stuff. rd main.storage buffer create position bytes.size position bytes. Okay. So this is how we make our buffers. I might look at the main component, the computator stuff for this for a second. To better understand making the resources. Oh my god, Nix. Yeah, that song was good. Sapphire, you're playing Hitman on your Steam Deck right now? Nice, nice. Yeah, I don't use my Steam Deck enough. It's really just for like traveling and vacations and stuff. But there's a lot of game formats that I only want to play on the Steam Deck. You're pretty sure you could still develop for Windows on Linux? Oh yeah, you can definitely do that. I just don't want to put up with it for my daily driver. I think Linux is going to be fun to experiment on like an auxiliary computer. But my main game that's doing all of this, I'm running the stream and Godot for one thing right now. The computer that I'm streaming on is the same as the computer that's doing all of this. Like I don't have a separate streaming computer. I just don't want to think about it. I know Linux is good and stable in most cases, but like I'm not there yet. I'm just getting my toes into like the messing around with Linux on another computer. I am not ready to make my daily driver a Linux computer. Yeah, I'm not ready. Someday I might be. But I don't want to have to worry about that. I also play games on here. I don't want to worry about that either. I don't play a lot of games, but you know, I do. Like, how's Arc Raiders on Linux? I don't know. You're just sticking your foot in as well. I think it's the time. I think if there's a time to, you know, be messing around with Linux, it is now. It is the death of Windows 10. Because I have a bunch of old computers that are still fine, that ran Windows 10, that allegedly can't get Windows 11, and I don't want to fight with them on it. I'm not gonna. It's fine. They're backup computers. I've replaced them, and I've got them sitting around, and they're not doing anything. And it's like, heck, I guess now's the time. Now's the time. I've settled on it. I think I'm gonna set them both up with Kubuntu, which is the KDE Plasma version of like Ubuntu. Okay, so what we do here, we make an array. It's funny how they make the array like this and then just do this 2-byte array. We don't really need to do that because we're going to be sending in a packed byte array already. We create a storage buffer. So buffer is rd.storage_buffer create input bytes.size input bytes. So you just create, and then what? Buffer is like an what do we get back from this? Like some kind of ID, like an RID. That's probably what we get back from this. Storage buffer create. We're going to be in this a lot. We're going to be in this rendering device this rendering device thing. This is like an abstraction for the low-level graphics APIs we're going to be using, and I'm very appreciative that Godot provides us this, because then I don't have to care or think about whether we're on Vulkan or Metal or OpenGL. Well, I guess I do care if we're on OpenGL, but I don't need to worry about whether we're on Vulkan or Direct3D 12 or whatever, or Metal. Which is nice. But yeah, so what do we do when we make a storage? Storage create. What was this called? Storage buffer create. I don't see a storage buffer create function. Oh yeah, there it is. Why is it? Do I just not know how alphabetics work? I don't. All right, storage buffer create. Yeah, we get an RID back. Okay, sick. RID is neat. Titan. Not trying to make you switch, saying that Linux seemed to have come a long way. Oh yeah, yeah. I'm excited. I'm excited to try it. Nanigans, Fedora runs beautifully on your 15-year-old laptop that can barely run Windows 8. Nice, nice. Titan. According to ProtonDB, Arc Raiders works perfectly out of the box on Linux. Hell yeah. That sounds good. That was just an example. Darren Ash, you end up using Windows with WSL or a Mac for developing. You never actually used Linux directly. Interesting. Yeah, I'm excited to try it. I'm definitely excited to try it. All right, so yeah, this is the annoying part about compute shaders. We have to like create our resources, register it in a way that like the GPU and the CPU both know what we're talking about and are in agreement about what we're talking about. Then you got to set up these uniforms. So like, yeah, so we take this buffer ID for this buffer we made. Then we make a uniform. We tell it what kind of uniform it is. We tell it what its binding is, which needs to match the binding over here. So like if our input buffer is at binding 0, it's got to stay that way. Whereas like our input textures are at binding 1 and our output textures are at binding 2. I don't totally understand what set refers to. Maybe there's a way of binding different sets of, like maybe it's just another level of bindings that we can use. Maybe this is for like other wavefronts or something. I don't know. I'm not going to worry about it. I'm still worried about this whole compute pipeline thing, which I'm probably going to spend the whole evening trying to sort out all this stuff. I'm glad we have a very clear path, though. I'm very appreciative to the Pathfinder's Codex for providing us a guide of how to do this, both in terms of code and in a video. Rhiannon, you've been using Linux as your daily driver for a couple years now. You love it. The only issue you've had is NVIDIA drivers sometimes have issues. You've just avoided those updates until they get stable again, but you get not wanting to deal with that. Yeah, that's the sort of thing I don't want to deal with. Like, oh no, I updated OBS and NVIDIA and now nothing works right, and I don't want to. I don't even know why I'm on Game Ready driver. I should be on the creator, the stable creator driver fork. I don't even know. I don't even care about getting the new game driver, the Game Ready driver normally, because I'm not usually playing new games. I need a cup of tea. I can feel it. I can feel it in like the back of my throat. It's like, Dave, go get a cup of tea. I think that's what I'm going to do after this. I'm going to go down to the laundromat, take my work laptop, do my laundry, sit in the coffee shop next to the laundromat, get some work done, have a cup of tea. It's going to be good. And then tonight I got another co-working event. We do kind of like a marketing-focused co-working event on Thursdays, which is nice. We got some videos to watch. There was a talk by Stay-at-Home Dev from GodotCon about being a content creator, and I thought it was really interesting. I actually got to watch it again today. That's what we're talking about tonight. But I was there. I was there. Probably see the back of my balding head in the video. Y'all have time to play games? I really don't, Nix. I have maybe 2 hours of gaming time, really. I have like an hour on the weekend that I use to play games with my friends. And right now what we're playing is maybe I have a couple hours on the weekend to play games with my friends. And usually right now we're playing Void Crew, which is really good. If you got a few friends and you want something that's like somewhere between Sea of Thieves and like FTL, go check out Void Crew. Void Crew is good. I've been really enjoying it. I'm kind of the ship's engineer / scavenger, and I have so much fun just running around the ship. The other guys end up doing the piloting and the gunning and stuff, and I'm just like, I'm like Scotty in the engine room, just trying to like keep things from falling apart. It's fun. Void crew. Oh, we're talking about something on text here. Yeah, that's funny. All right, what are we doing? What are we doing? We're setting up something still. So we did the ready part, but then we go down to this restart simulation. Restart simulation. I'm just looking at how they set up all of their data. We don't care about the simulation stuff they're doing, but I am interested in how they set up their project. It's pretty smart. I'm going to think about how to maybe do my own kind of little startup system that only runs when we either start or restart. We rebuild the buffers, we take the data, we clear the buffers and the uniforms. I'm not concerned about rebuilding the data at the moment, but that is an important thing to consider. We're also not here, we're like over here. So we get our data. Here we like split the data up, but we don't need to do that. So what we can do here is we can say like func. We can say like func, we can say like receive. We could say update. Input buffer. And we'll get a data as a packed byte array. You're just upset that nothing's happening here? Yeah, okay. And so what we're going to do here, when we get this new data, what we're going to do is we're going to do this part. So buffers.append. Why is buffers an array? Is it because we have more than one? So I don't need to do it that way. We can do it this way. So compute buffer. I could say compute input buffer. Doesn't need to be an array. It could just be an RID. We'll say compute input buffer equals rendering device storage buffer create. So we need to know data.size. And then we can just say data okay, that'll work for that. What else do we need to rebuild here? So they have input output buffers. We just have one input buffer. They have this output texture. Darren Ash, do you have any good podcast talks that you would recommend about game development? Recently, you saw a GDC talk called Cursed Problems in Game Design. Ooh, Cursed Problems in Game Design is really good. That is by Alex Jaffe, which I think is a different Alex Jaffe than the Alex Jaffe of insert credits. Yeah, let me tell you something right here. There is one game dev podcast I listen to, and it's Coffee with Butterscotch. I actually have half of yesterday's episode. I still need to listen. It's on YouTube. It's also on their own website. What if I just do this? Oh, it auto takes me to the next one. Okay, so if I just put this in. I like this. They do this every week. Nanigans, I piqued your interest on Void Crew. You indeed enjoy both FTL and Sea of Thieves. Yeah, it's really neat. It's not like Sea of Thieves in that it is not PvP. I think there's another space game that's more PvP oriented. Void Crew is closer to FTL in structure, where it's like a roguelike, and you and your friends start out on this ship, and you try to go through a run, and the enemies get harder, you fight bosses, and like you upgrade your ship as you go, but it's all PvE co-op. It's really good. But yeah, Coffee with Butterscotch is really good. It's a really good podcast. It's by the devs of Butterscotch Shenanigans, who are the people who made Crashlands 2, Levelhead, you know, a bunch of older games too. They're working on How Many Dudes, which is a very funny... Actually, it's a global game jam game, I think, that they're pushing. And they're having a lot of really good marketing success with it. So they've been mainly talking about that now. But they talk about a lot. They talk about how to structure projects. They talk about DevOps. They talk about marketing, design. It's three brothers and their podcast about them making games. I highly recommend this one. It's weekly. It's about an hour every week. It's really good. That's my recommendation. You were looking for something to listen to when you're doing the shopping or cooking. Yeah, I'm actually not a big podcast guy. It's interesting. I'll sit on Twitch or YouTube or whatever, but like I actually only have like I have that podcast, which is my main podcast, and then I have a backup podcast which is not games related that I don't even listen to that much, but it's like my I'm going to clean the house, let me put on a podcast kind of thing. So I'm not an expert. You could probably check out the Scope Creepers podcast. That's Aramis's podcast. That also has a lot of good interviews. I feel like there's a lot of good interview podcasts. All right. Are we going to actually get any more work done today? I think the answer is maybe. So I like that this is all set in like a rebuild function. Sam, your podcasts are basically me on the background while doing something else. Yeah, I think I do the same. Like at night, it's usually watching Adam C. Eunice working on their game. And then during the day, I'll have whatever on in the background. All right, so we do need to set up this image. So maybe we'll have like a create output texture. I'm going to just put these in functions for now, just so I have them a little organized by what they're doing rather than just have it just be in a pile of code somewhere. So we can say, so do we need this image? This is a local variable. Why do we... I'm a little curious about how this works. Texture rd.texture rd equals output texture. Texture rd.texture rd. Interesting. Interesting. So this is output texture rd. I should rearrange some of this stuff. So we can have a local variable. We can do output image. Image.create. We're going to create it from I'm setting the size of it here, or up here. Why am I having to do that again? Oh, whatever. Whatever. We'll just do viewport width and viewport height. Viewport width, viewport height. What's the third? Use MIP maps. Oh yeah, false. No MIP maps. Pixel art. Image format .rgbaf. Oh, image dot format RGBA F. Okay, what are you upset about? I'm not using this anywhere? Yeah, all right. All right, and then so our output texture is rendering device, not rendering server, rendering device, texture, create. Why are you so upset with me? Rendering device not declared in currents. Oh, render device. I just call it render device. Texture create. Maybe I take the word output out of a lot of these. I'm really curious about how I handle this with input textures. I don't feel like this person is doing any input textures. So that is going to be one of the areas in which I'm going to struggle and have to experiment with, is how to set up our input textures to be correct for this. So I'm going to continue to refer to these as output textures just so I don't get any of that stuff mixed up later. Because you know I will. You know I will mix it up. And I won't be able to figure out where the problem is. Output texture format, output texture view, and then an array of the output image dot get data. This is very curious. But I see how this will work. It's very neat. All right, and then what we do, so we got that. And so what we want to do is we say texture RD. I don't know why we're storing the texture RD separately. Well, what did I call this? I didn't call it texture RD. Did I call it like texture RD, output texture RD dot texture RD RID equals output texture. All right. We're cooking here. What the heck is this texture? Oh, we got to put this to the display node. Oh, yeah, we're going to have more than one output texture, huh? Forgot about that. I'll have to think about that. We can probably use the same format for all of these, though, at least. But yeah, we're gonna have a texture per Z index for now. I think eventually I do want to do some kind of texture per compartment thing, or a couple textures per compartment. There are some issues of like compartments that interact weirdly with other compartments where it's impossible to tell which is in front of the other, and there's rendering concerns there. But I'm kind of interested in doing something like that. Our problem is that the way we're doing the rendering is not like easily parallelizable unless you start splitting everything out by its Z index. Because the draw order like matters, as it often does. Draw order matters. What happened to our ad manager? Our ad manager has died. I don't know when it's going to try to run a new ad, but I'm going to have to stop it. We're going to have to try to stop it. All right, so here's the main difference between our use case and this individual's use case. One is we have multiple output textures. Another is that we have multiple input textures. So they're also building the shader and pipeline here. They're working out. There's something here about the output textures uniforms being bound, which is good. So wait, do we bind? No, this is the textures uniform. So we make a uniform. This is how we can access it in the, this makes sense. This makes sense what we're doing here. So here you can just iterate through all of the uniforms. There isn't anything special about... Oh, so we're iterating through all the storage buffers. We're binding them. We're getting the RIDs. Yeah, it's crazy how much work that we need to do just so that everyone is agreed about what resources are where and what we're talking about. There's so much of this to do. But yeah, we're kind of at our 5-minute warning, so I think I'm going to put a pin in this right now. What we're doing, just for anyone who's actually managed to stick with us the whole time, is we're trying a different rendering approach, because right now we're rendering with canvas item, and it's too slow for what I want to do. And because we don't actually need anything back from this stuff, like we aren't doing the usual thing of having the having everything be like a sprite, like a bunch of sprite 2Ds in the scene tree. We're kind of taking a very rendering only approach, where Godot's only job is really to handle IO and rendering, but it's pushing us into a very extreme solution where I'm considering doing all of this rendering from a compute shader. And I think that's really the only way to unlock extreme performance here. So that's what we're trying. That's what we're trying to do. Some weird flickering with some of that delay. I'm hoping doing it this way, we can actually just also cut out a bunch of some of the optimizations we were doing on the simulation side when we were trying to like reduce the number of stuff drawing and everything. I'm hoping that the GPU is so fast that we can actually offload a bunch of additional work there, at least in terms of the rendering, so that the simulation layer is not spending quite so much time trying to do it all itself. But hopefully we'll bring it into a balance where the CPU and the GPU are similarly tasked. We want both of them to be very low, but we want them to be similar. And right now, the CPU is like very high utilization. The GPU has almost no utilization. And even though the CPU utilization is at a point where we could probably manage it, I just want to bring the whole thing down. And I think it's going to be something like this. I think bringing the GPU up a little will take a lot of the weight off of CPU for the rendering, which is where we're spending most of our time in the CPU. So yeah, that's the plan. I'll keep working on this tonight, and I'm sure we'll keep working on it tomorrow. But yeah, I hope to have more of this rendering stuff soon. I'm excited about this approach. We'll have tried 3 different rendering approaches in like 1 week, which will be fascinating. But that's kind of what game dev is. You kind of figure out what your requirements are. And a lot of game dev is trying out a method just to decide that's not the right method. Like, it'd be great if you could preemptively guess what you were doing, but unless you've made the exact game before and you're making it again, it's really hard to tell what the exact use case is and what the exact requirements are. Good night. Thanks for the stream. Good stream. Thanks, Nix. Thanks, Darren Ash. Have a good one. Thanks, Digitanigans. Yeah, you guys as well. Sorry for the short stream. We kind of hit a bunch of unfortunate things that all kind of conspired. I like to do 3-hour streams, but compute shader's so hard. I'm kind of glad we ended up with just a 2-hour one. Thanks for the hydrate, Nix. I'll try to remember when I'm at the coffee shop drinking my tea. Jacob, you said already, but you're stoked for compute render stuff. Yeah, I think it'll be fun. I think it'll be fun to see what we can do. We'll hate it. Us from a year from now, who's trying to figure out how to do the lighting, is going to be like, why did we have to do it this way? But right now it's a good idea. And if we end up baking most of our lighting and stuff anyway, it'll be fine. All right, take it easy, Sapphire. Yeah, good luck tomorrow, Nix. I hope I see you all soon. Space is dark. There is no light. That's a good point. We'll keep that in mind. Thank you all so much for watching. Hope you have a great rest of your day, and I will see you all next time. Bye.